All right, guys, let's look at worksheet number 3. Now, notice at the top of worksheet number 3, it says segment and angle bisect and midpoint. So most of these proofs we're doing here has to do something along the lines with segment and angle bisectors and also midpoint. So before we do this, let's go and look at what segment bisectors, angle bisectors, and midpoints mean. Okay, so this comes straight from, I just snipped this from one of those 4 sheets you had with all the definitions and theorems and postulates and all that. And so on here it says the definition of a segment bisector is a point, ray, line, segment, or plane is a segment bisector if and only if it intersects the segment at its midpoint. Okay, so if line M is a segment bisector, that means that F has to be a midpoint. Okay, and if F is a midpoint, read this one here, at point F, if and only if PF is congruent to FQ. So this side is congruent to this side. So if it tells you that something is a bisector, there should be a red flag that you have 2 parts that are congruent. Okay, that's what bisect means. Guys, this is the same thing for an angle bisector, except now you're bisecting an angle. So on a segment bisector, you have 2 parts, and those parts are segments are congruent. And on an angle bisector, all you have are 2 angles that are congruent. Okay, so segment bisector and angle bisector, that's what those tell you. Okay, now if we go to definition of midpoint. Okay, and this is kind of the same thing. They're along the same line, which is why we grouped these the way they did. If M is the midpoint, right here, if and only if AM is congruent to MB. Okay, so once again, anytime you hear that something is the midpoint, you should be thinking 2 congruent segments. All right, let's go back and do some examples together. So we're still going to continue to use all the things we've used up until now. Now we're just adding in the angle bisect, segment bisect, and midpoint. All right, so let's look at, under the notes, let's look at number 1. All right, it says A, B, and CD bisect each other at M. Okay, so AB bisects CD, which means that CM and MD are the same. And then AM and MB have to be the same because this bisects AB. All right, so we're given AB and CD bisect each other at M. So notice that's what's given here, and we just write that word for word here. Okay, and then we're also given that MB is congruent to MC, which is right here, and both of those are given. Okay, we just did that word for word. That's where those came from. All right, so like we had already talked about, MC is congruent to MD. Well, we know that because of the word bisect. So this would just be definition of bisect. Now, likewise, we know that MB and MD are congruent. Well, how do we know that? All right, so if we look at 2 and 3 together, guys, here's MC here and here's MC here. We know that both MB and MD are congruent to MC. So remember, that would be the transitive property of equality, or property of congruence, I guess, since there's a congruent line. So if 2 things are equal or congruent to the same thing, they have to be equal or congruent to each other. All right, now MB is congruent to MB. Or MB is equal to MB, I'm sorry. And as we've learned, and we should be pros at by now, that's just definition of congruence. Anytime something is congruent, we can say they're equal. If they're equal, they're congruent. All right. Now, if we look here, we have the segment addition postulate. Okay, well, anytime we have segment addition postulate, that means we need to go to the diagram. We need to read the diagram to come up with what we need. All right, so if we look at 7, I know I'm kind of jumping forward, but it's AB equals AM plus MD. So I'm guessing that we need to figure out, according to the segment addition postulate, what AB is equal to. Okay, so if I look here, AB, which is right here, I can say AB equals, well, it's AM plus MB. That's the segment addition postulate. Okay, now if I compare 6 and 7, notice that they're the exact same, except this is an MB and this is an MD. Well, how can I just put an MD in for MB? Guys, they're the same. Okay, so I can substitute MD in for MB, which is what I did here. So I can say substitution property of equality. And I put line number 5 in for line number 6. Okay, I put what's in 5 in for 6. All right, let's look at example number 2 now. So we're given 2 things. Well, actually 3, because we're given a diagram too. But we're given that O is the midpoint of MN, so I'm just transplanting that right there. That's given. And I'm also given that OM is equal to OW, which is right there and there. All right, so step number 3 tells me MO, which is right here, is congruent to ON, which is right there. So I'm going to ask you, how do we know that MO and ON are congruent? Well, guys, we know they're congruent because O is the midpoint. Okay, so just like we did back here, if it's the midpoint, then the 2 segments are congruent, right? That's exactly what we did right here. O is the midpoint, so the 2 segments are congruent. So this would be definition of midpoint. I'm going to abbreviate that. All right, now number 4, notice we have to fill in the left side of the equation, but the right side is given. And the right side is just definition of congruence. Okay, so we know that 2 things are congruent are also equal. So MO equals ON. Okay, now I'm given MO is congruent to OM. Okay, guys, all I did here is I switched the letters, the order of the letters, right? So if I look up here, OM is this segment here, and MO is also this segment here, so they're the same thing. So that's just saying symmetric property. All right, now I want to substitute line 5 in for line 4. Okay, so notice I have an O or an MO here, so I'm going to put the OM in for there. So I'm going to say OM equals ON. Okay, well now if I look from line 6 to line 7, it's the same thing except now my OM has changed to an OW. And the reason it can do that is because of this line here. OM and OW are the same, they're equal, so I can substitute OW in for ON. So I'm substituting line 2 into line 6. And we are done with the second proof.